How's the audio? Hearing me okay? So some of you remember electronics lab, at least Heroy and Topher. Others of you maybe are a little different vintage and remember electronics lab when it was half this big and twice this dirty. We are actually in the middle of the final exam assigned to the electronics class. So the folks in here are trying to finish their projects. This particular course is a required course for majors. I know back in the day, you used to do it all in one semester and it was uphill both ways in the snow. What we have now is we've taken electronics and made it a little more flexible so that it's a little easier for people who want to go abroad. There are a few more options. So we have our electronics split into 3 half-semester courses. Physics 380 is the good old introduction to analog electronics that everybody takes with Thevenin and filter circuits and power supply sort of stuff. And we finish it up by building power supplies. So every student learns to build a power supply that you can plug into the AC and get 5-volt DC out of. And lately we've been having them include a USB so they can charge their phones off. If they're building it right, I will plug my phone into it and show them that they can charge. So sometimes they're a little afraid to put their phones in, but after I've checked the voltages, I'm usually okay with plugging mine in. After that, halfway through the semester, we segue to a different course, depending on which year it is. So just like our upper level theory courses would be alternate years. One year it's classical and quantum, another year it's E&M and stat mech. This year, it happens to be our introduction to digital electronics for the second half of the semester. And in that course, they're learning a little bit of the old traditional logic gates and stuff, and then a whole lot of digital circuits with Arduinos. So by teaching this microcontroller platform, we get the power of being able to turn some of our electronics into software instead of having to do all the hardware by hand. That has enabled a new end of semester project where we give them a budget of $40 plus the Arduino that we bought from at the start of the semester, and they can build whatever they want within that $40. If they want to put in a little extra money of their own, or if they have other things, they can add to it. I see Phoebe has come on. Phoebe, I still have all of the stuff from your project. It's in my lab. Anytime you come to Kenyon, you can pick it up.
Thank you for housing that.
I've been telling people that the best project is one that you want to take home with you, one that you love so much that you would not consider leaving it in my lab for the next 15 years. So that's what I'm after. So I'm going to show you a few of those projects, let you ask questions. There are some students who are working. Occasionally, if somebody needs to ask a question, I may ask one of the students to show you what they're doing so I can go and answer a question or do something in the shop. For those of you who aren't that familiar with the new building, though, I'm going to walk you around. Let's see. I also hooked up an iPad. Yeah, sure, you're welcome to try to answer the questions. But remember, most of the problems with electronics are fixed by the aura of the professor standing nearby. It has very little to do with the actual content. It's how I poke the wires and stuff. Yeah. By the way, I got to say, I'm intimidated as hell to be talking about electronics in front of Topher White. Just so you know, Toph. Okay, so here's the electronics lab. We have room for 20 students. And believe it or not, 20 students is not an unusual number to have in our electronics course. Students are taking it typically as juniors, sometimes as seniors. So if they've gone abroad part of their junior year, they may come back and take their electronics. It's looking a little bare here. Normally it's an even bigger mess because all of the scopes and everything would still be out. But a lot of students actually finished their projects early. So we're getting to the point where it's getting cleaned up. This is part of our advanced lab area. So there are rooms that connect here. This one's mostly electronic stuff. Here's some condensed matter physics and some X-ray stuff. And there's a whole chain of rooms down the hallway. But I want to show you the most important room for building things, physics shop. Again, this is a real step up from where we were 21 years ago when we were in Sam Mather. There we had probably 1/3 this room and almost all this stuff. We've recently upgraded our cutting tool to a saw stop table saw. This is the kind of saw that if you happen to get your finger against the blade, it throws a block of aluminum into the blade and quickly stops it so that it doesn't cut you.
Those are so cool.
They are really cool.
Yeah, those are amazing.
We had to really reorient the shop though, because the way we were thinking about doing it, we wouldn't have had 8 foot of infeed. So if you want to try to rip an 8-foot piece of material, you got to have at least 8 foot of room before you hit the table, and then 8 feet after. So this is a work in progress. It's still the folks at Kenyon fabricated the new base. It's just a steel tube, put our old tabletop on it. And my job over winter break will include getting them back here to install the electric and setting up the saw. But we got, bandsaw, disc sander, some sheet metal stuff, a shear and a brake, a fairly new lathe. We bought this in 2000 when we moved in the building. A Bridgeport Mill, which is the gold standard of mills. This one was made in the year I was born, 1964. So this is almost 58 years worth of machining glory. It's a beautiful, beautiful tool. And then we have, stock storage and drill press and yada, yada. This room has been heavily used recently by students trying to get projects done. There's been some basic construction as well as more sophisticated stuff going on. And I'd just like to show you some of the projects. I don't know how this is going to work in terms of tech, but where did I put? So I'm just going to show you stuff and you should stop me and ask questions as you like. Olivia's working on soldering and she's trying to solder what are called Neopixels. You want to show them how big those Neopixels are?
Oh, so big. This is my pinky for comparison, and that's little white end is. There we go.
Yep. Not fun. This is a surface mount device, so we're trying to use it in an environment where we don't have, we aren't building our own boards so that we can then surface mount. What you do with the surface mount is tin it with solder, set it on the pads, and then heat it so that in an oven, you can even use a toaster oven from what I hear, it would melt to the right pads. No, we're doing it the old stupid way, trying to put big fat wires on little tiny connectors. And it works about as well as that sounds. Let's see. I guess what I'll do is just start wandering around and showing you what I can of projects. One of the recent ones that just recently started working. One of our students has a dad who does RC airplane stuff, and he let her have one of his old planes. So this is our test stand for the plane. We've got it hooked with some spring clamps to a big ladder so that she could start the engine and make sure that that worked. And she's wired in a new control board to all of the servos. So RC plane, you're trying to use the servos to change the flaps and the rudder, and you need to be able to power the engine. Now, if I remember correctly, we might be able to start this up. That's the happy sound of the electronics saying hello. And then the controller that she built, you can see, is 2 joysticks attached to an Arduino board. And this thing hanging off of it is the transmitter. Okay, so I've turned on power. Am I pointed at the right thing? And I think we'll just turn it like this to watch the plane. That looks pretty good. So I've got control. Pitch and yaw. And where's roll? There we go, there's roll. So to roll the plane, you're trying to turn it around its main axis. You have to turn the 2 flaps counter directions, and you can roll either way. May demonstrated for me, but I didn't think to ask her which thing to push to get the engine started.
I think you hold the rudder, the throttle down for 3 seconds.
3 seconds.
Like,
Cool. Thank
yeah,
you. 1, 2, 3.
I think you actually like rotate it there. Not push them. There you go.
Nope, nope, stop now. You're done. Go lie down.
That's pretty fun.
This could be a really long demo if I can't get it to shut off. 1, 2, 3, 4. Nope. That's okay. I know how to fix stuff like that. So she's got a working RC plane. Still has some dressing to do on the wires to get things in a way that it's going to balance, because the Arduino with the Arduino Mini is a little heavy. So she's going to find a place where she can mount that so that it's a little better balanced. But she's hoping to be able to fly this with her dad when she goes home for break. See what else we've got. I just got a demo from somebody who built a robot with an auto driving mode. Here's how they leave their stations. There's the thing, there's the lab notebook. You all remember those, right? And
Still
directions.
have them.
So everybody's giving us these little sheets of what to do when we test out their projects. For this one, we need a little bit of floor space. There's a standard driving mode. So on the remote, if I hit the forward button, it should go forward. And if I hit the center button, it should stop. Reverse. Turn left, turn right. But more fun is if you hit the mode button, it stops and looks around with the ultrasound sensor to look for obstacles and decide what direction to turn and try to proceed.
Object detection with no software. That's pretty fun.
It really can't decide because it's found two things that are equal distant. So still some work to do on the programming there, but it's certainly doing a lot of fun stuff. Come on, you stop now.
So what do most of your students program in, Paula?
What's that?
What type of programming languages do your students usually use?
Well, in the sophomore year, they take a course in computational physics that starts them on at least C++, and often some Python. About half of the course is also Mathematica. So it's not like they're spending a whole course learning C++, but they're getting started in C++, depending on who teaches it, sometimes some Python at the end. Students who do research often do Python if they're working in the LIGO lab. So
Hi.
Kelly is in LIGO lab. She programs in Python.
Yeah, very good.
Using mostly C.
C.
Yep, straight C.
Mhm.
Occasionally there's Fortran. What are you guys using? Do you have anything programming wise in Cold Atoms?
Jason uses Mathematica. He's been working on a big order Rumpicata. I use Onshape CAD software. I don't really get into much of the coding with my job.
Yeah, well, and Emily's learning to use the mill. So she's our most recent mill user.
Ah, very
Maybe
cool.
not
That's a
most-
useful skill.
Maybe not most recent, but she's the one been using it for research. We had a student who learned to use it for this project. Let's see if I can. Yeah, it's looking okay. Her Arduino is connected to a humidity and temperature sensor inside this glass terrarium. It's actually just a glass bowl, but she's turned it into a terrarium. It's got a resistive pad that will heat up, and a cup with water and this little ultrasound humidifier. So if it floats in the water, it can use the same technology as your, one you leave on at night in your bedroom to humidify the air. And it's just a checking with a a certain cycle, the humidity and temperature and running the heater or running the humidifier as needed. It's a little bit larger, so the plant that she had brought in to put inside didn't quite fit because of the size of the cup. But she learned to do milling with the circular mill table to make the indentation that helps seal this. And then she got fancy and also indented spots for her Arduino and stuff. So that's just milling on wood. What Emily was doing this summer was milling metal and some pretty tricky cuts too. Let's go down the bench here and see what we've got. Haven't seen this one work yet, but this is a pulse sensor. So the sensor's inside here and there's an LCD to read it out. And if we get the Arduino plugged in and turned on, see what all it does.
I think Clay was saying earlier that that battery pack is dead.
Oh, okay. All right, well, we need a better 9-volt.
This one is loose.
I'll borrow that one. No, you know what? I'll borrow this one. It's not even plugged in. One of the nice things about Arduinos, if you're not familiar with them, is they're a really easy entry-level platform for people to learn to use. They can be run off of a 9-volt battery, at least for a limited time. 9 volts are not my favorite. And the logic by which they operate is just that you set up something called loop. So you're naming a function loop. And the Arduino's job is just to keep running loop over and over and over again. So for instance, in the humidity sensor project, Manur sets it up so that it's checking temperature and humidity. And then she puts in a long delay because you don't need to check that every clock cycle through this program. So if you delay for long enough, you can check it every 5 seconds or something and still be able to get pretty good control. So in this one, what will happen is it'll boot up and start sending things to the display. Now, I'm not sure how the video is going. Can you read that? Yeah, okay. So BPM, beats per minute, is 0. If I put my finger in the sensor, let's see what I get. 0 for a while, then it was 94. 27, I don't think that's right. 28. Okay, in the 30s or 40s, that's probably more reasonable. Although why it's ramping up, I don't know. I'm gonna have to talk to Clay about this. And this one's just mounted on a board with a little enclosure. Mason, do you have a moment to show us your thing?
Yeah.
Mason's next in line here. And I'll just let him explain what his does.
So these things are called useless machines. It's got a switch, and then when you switch it, the box opens up and flips the switch again. So it's just turning itself back off. But I do have, so I have a total of 3 servos and 2 motors. So, and an LED light and a speaker. So there's a lot of customization you can do. You can see some steps are different. I have 18 steps, I think, that it cycles through.
Yeah, see, the box starts to get some attitude after a while.
Yeah. So right now, I don't know if you can see, but I have a light in there and it's buzzing. And I even got motors, so the thing will drive away from me. And oh, I got police sirens going.
Nice. That's
Yeah.
fun.
But yeah, it was fun. There's a few songs in there too. I think the Star Wars theme song is in there. So, yeah, a lot of customization.
Very cool.
And I have an open port on the side that in the future I can come back and change it because everything is everything's enclosed. So I just plug in and I can fix the code. This is one of the songs.
Isn't this the one where it starts dancing?
Yeah, eventually it is. Yeah, it starts spinning. Sometimes it has a tough time on the surface. But sometimes it can get spinning around pretty good. And it always flips a switch.
And
this
here's the
is-
Imperial March.
Yeah. Yeah, the coding community online is really, they always have something. So like this, like the song I got from online, because I'm not musically inclined, but everything else is my code.
No, that's fantastic.
And then this is the last step.
That's a good time.
It's almost the last step, but it turns out that the box always gets the last word.
Yes. How long it takes. There we go.
And now it's laughing.
Yeah. So that's it.
Thanks, Mason. Yep. So you can see that there's a whole lot of creativity going into these projects, and people are having a fair amount of fun with them. What else do we have? Who's here? Let's see if Callie's got time to show us. Callie and Olivia are busy working here on these damned Neopixels.
Found a different library that was more compatible, and now it's just not.
Individually, they're working.
Individually.
But then it doesn't want to do like the second one in the sequence.
You might have to check your environment. So if you're running different versions of Python, certain libraries won't run. So check which version of Python you're running first.
Well, it's not even Python. This is a development environment that's particular to Arduinos. So there's a
Okay.
Python version of it, but the one we're running is the standard Arduino IDE.
Okay.
So, but you're right, it could be something about some under the hood business of that. I haven't had necessarily that experience with the Arduino IDE. On the other hand, the Neopixels tend to be a little fussy. They're a programmable red, green, blue that can be daisy chained together so that you can make sequences. And I'm going to have you look at May's project, and I'm going to have her, or sorry, Callie's project, have her explain it to you. But I'm going to show you inside, there's a Neopixel ring. So those white squares underneath the character, those are Neopixels as well. So here, can we turn this around so I can set the computer down and see where it's pointed? Okay, so tell them about your project and what it's for, and then do a demo.
So my project is a snow globe without the snow. And it's just meant to spin and play music and just have this character. It's for my little brother. He's 8 years old. It has his favorite character in it. And it's something that's going to be taken home and used over and over until it breaks, which I give it a week.
But at least you'll know how to fix it for him.
I don't know if they can hear it, but
Who is that guy?
Soros.
Soros?
Probably an anime character of sense. Not sure.
a video game character.
Okay. Gotcha.
And that's his theme music that's playing from the video
Gotcha.
game.
That's cool. He's gonna love that. Video game people always love soundtracks. I can still recite many levels of Bowser in Mario Brothers. So
Thank you.
Yep, lots of joy. That's going to be a fun one. And what Olivia's working on with Neopixels is a Neopixel Clock. Do you want to tell them a little bit about your vision for it eventually,
Yeah.
once
so-
we're done fighting with the Neopixels?
So I ordered an RTC clock module, which does a lot of the heavy lifting. But the goal was to install these awful pixels in like an arrangement on a board and have the larger ones be the hours, and then install 48 smaller ones around it for the minutes. And I also have in the other room key switches to kind of, so the goal is that, for example, if it's like 1:43, the one LED will light up, and so will the 43rd minute, and have it be customizable like color wise with the 2 buttons. Yep, pretty simple.
no,
Well-
that's very cool. Those are
No,
hard to organize.
it straightforward is different than simple.
Yeah.
It's straightforward in concept, but making something work is almost never simple. So that's part of the lesson that we learn in project-based learning, is that there's always more to it. And in your case, getting the pixels arranged and working is going to be the challenge. And I think we need to switch to stranded wire, because I think the solid core wire is going to be a problem, but we'll talk about that later. So Josh is working on something. I'm hoping you can tell him a little bit about what you're headed toward.
I could tell them a little bit, but I don't have much to demonstrate right now.
That's okay.
Basically, so I actually have some sketches that can help show
So
this.
weird.
Um,
Maybe 1 and 2.
but I have this LED matrix, little 8x8 thing of LEDs. And so basically I'm building a circuit that is going to use this tilt switch. So basically this, I don't know if you can hear on the computer, but if you can hear in the microphone.
No, I didn't even read that.
When you shake this, there's,
Yeah, it's a little cylinder with 2 wires, and the outside, guys, could you keep it down just a little? It's the cylinder is connected to ground, but the center pin is connected to another spot. And when it's held upright, the ball in the middle connects the 2. But if you turn it over, the ball falls off the middle pin and you lose the connection. So it's like the world's simplest switch.
so basically I'm trying to make an electronic die so that if you shake it, it'll generate a random number and then display like a die on the LED. But then I have some sketches here I could actually show you. I was trying to figure out how to make it work for more than 6 sides. So I don't know if you could see up here, I have like 1 through 6, and then I'm going to have it go 7 and 9 still with dots. But then I was trying to figure out on like an LED how to make it display numbers, because using dot patterns probably isn't going to be possible and still, like, you know, look pretty in any way beyond 9, but I might be able to have it just display the actual numbers. So it's going to be like a little electronic die that you could use if you play D&D or anything like that. You need some weird number of sides that it would be hard to buy a die to do.
And so is that what the push button is, mode selection?
Right now, I was using the push button to generate random numbers before I put the tilt switch in, because I was working on actually trying to figure out how to generate numbers more randomly than just calling the random number function in Arduino. But it actually turns out trying to, without like buying some other equipment or trying to find some other physical process, I found some things online talking about using the analog pins on the Arduino to read whatever voltage it is, because you'll get different values based on just noise to seed a random number. But on any one pin, the values are always so close that it always gets a very similar seed and will tend to repeat. And so you end up getting much less random numbers than if you just use the random number generation, which I guess is why they do it that way. So I'm going to end up just doing that and seed it at the beginning with one of them. So it's slightly random every time you restart the program, but I was not able to find a better way to do that.
Okay, in the time given.
Yeah.
Oh, my goodness, look at how this, we have RowBuddy instructions. Please be gentle, he's a sensitive soul. We also have lots of leftovers. Unused piece of soldered circuitry. The reason that's unused is because once he got it soldered up, it didn't work again. So we went to a different system with a tiny breadboard. We've learned some lessons. I now have better instructions for people. If you're going to use motors, you need a battery pack. One of the things we found over and over again, and I knew this from previous iterations too, if you're trying to run motors and then you want to do a couple of servos, this one, for instance, like the other robot we saw, has a servo that's going to turn the ultrasound sensor back and forth. You pull too much current for the motors and then other things stop working. In this case, it was these infrared sensors. These are used for obstacle avoidance. So this is an obstacle avoidance robot with an ultrasound sensor that's trying to follow a person. So this student had the idea he wanted a little robot buddy that would follow him around. So he's programmed it so the ultrasound sensor swings back and forth and tries to follow a surface at a certain distance. So it's always trying to maintain distance from a surface. Now, of course, it can get confused by other surfaces. But the idea is then that the obstacle avoidance is being done by the infrared sensors and the ultrasound sensor is doing the following. So let's see how this one does. And I think I'm going to take it somewhere a little further from all the chairs. Okay, found an obstacle. It negotiated its way. Yeah, there might be a sign error in that programming. Come on, buddy. That's it. There you go. Okay, here's another obstacle. How do you do? So he's having a little trouble with the table legs. Here, I'll let him free again. Okay. All right, do it, do it. Yay, obstacle successfully avoided. We're going to stop with that. Oh my goodness. Here's one Tim and I decided we need a disclaimer on. This is an Arduino connected to an alcohol sensor to be used as a breathalyzer. So when we turn it on, if there's no alcohol present, we should get a green light. It's going through its checkout right now. Either that or I'm very drunk. That's also possible. Come on. I think it is stuck in the drunk mode. So I'm going to turn it off, maybe come back to this one. They've installed hand sanitizers in the hallways. So I'll go get some alcohol on a piece of paper towel and try that one again. Let's see what we've got. Here's one that's a keyboard system. When I saw it demonstrated earlier today, it was definitely making sounds, and the sounds went along with these pixels. This is a Neopixel strip, which is by far a more robust tool than the single Neopixels I have found. So if we turn this on, the LCD says, "Welcome to my synthesizer." It's going to use eventually it's going to be programmed with 3 different wave functions: sine, square, and triangle, I think. At the mode button. Choose your key. So by pressing a key, F natural minor, it lights up the pixels corresponding to the pitches in the F natural minor key. C natural minor. So C minor has its keys lit up. So it's sort of a learning tool for key signatures. C sharp, D sharp, D natural, F natural, etc.
That's pretty cool.
And eventually, of course, it's also playing back to the speakers. I don't think it currently has a system for memory, so it doesn't have memory to play back songs. But that's coming. That'll be in the next release. Here's another Neopixel project. Does somebody have a phone with some music loaded that they could loan us? Yeah, I just need to play some music for Natalie's. The speaker, and we'll see how it does. Like this one has a power supply, so we plug it in. Is this you guys playing? No.
Is anyone else taking those lab notebooks? Those old school lab notebooks?
What's that?
Loving those lab notebooks.
They bring back happy memories.
Happy memories or
Oh, of course,
Only happy memories. Only happy memories.
including sitting in front of decaying radioactive sources accidentally. I mean,
Yeah, I was gonna bring that
inside-
up. Really. You and I probably still nursing that one.
Yeah, I know. No lasting effects, really.
So this is set up with some filters. There's a high pass and a low pass that are used to change colors. We're looking for some music with enough high frequency content that we'll get some of it changing. Because the red's mostly just responding to the bass. Well, not there yet. Thanks, Josh. Oh, I'm sorry.
That did something.
Yeah, that did something. So it's high pass to get the response in the blues. I did see it earlier today, but can't get it now. Dropping the phone did make it turn blue. That's true. Do you want to explain to our guests what you're doing?
I can. I haven't, unfortunately, don't have that much to show for it, but I am making a motion tracker PIR portrait. So this is the start of the painting, and if you can see, it has a mechanism to move the eyes back and forth. And then I have a setup here that I kind of prototype that has 3 PIRs at different angles.
PIR stands for passive infrared sensor. So it's the sort of thing that turns on your lights at night when you go into the bathroom.
And so basically it can track movement back and forth. And there will be a servo on the back that will hold the little slot accordingly, so I can make the eyes of the portrait colorful. Yeah, that's
Cool.
what I have so far. Do we have any kind of like string? Just any plain string?
String. I do in my lab. Remind me once the Zoom is done, I will find you some string. My lab is filled with junk. We've taken to calling it the room of requirement because when we need stuff, that's where we go and we try to dig it out. Sometimes it works, sometimes it doesn't, but works often enough that it's worth calling it. So Alex, can you give us a little tour of your project?
Really?
No? Tell what the plan is. You've
Sure,
got an
okay,
ambitious
so-
plan.
This is a device that would help me when I'm like transcribing music or trying to arrange a song. So it can detect the pitch that you sing or play at it, and it will also work as a mini piano. And I'm hoping to get it to be able to store some notes when you tell it to, like press a button to store whatever notes it's hearing or whatever notes you're playing while the button is pressed.
And tell them about your awesome scrounging.
So I got some like random toy from Goodwill that had a keyboard in it. So I took it apart just to see how the keyboard worked, but I decided to actually use the like silicon buttons that it had underneath the keyboard for my project, which is very nice, but I have to work with this circuit board that came with it. So I've had to like figure out where all the traces are going and which ones I can cut and which ones I can't. Yeah.
Any questions for Alex?
That's very ambitious project. I wish you luck.
It is indeed an ambitious project. Yep, you got that one right. So I'm trying to see what else is lying around to show off. We've caught up with almost everybody who's in lab. One of the students who finished the project pretty early. I haven't gotten a tour of this one lately, so I'm hoping I can figure out how to turn it on. It's the third of our robots. This one is set up with a driver, 4-direction fob to drive it. You can go ahead past if you want. There we go. And if you pull the battery pack out, you should be able to find a starter switch, I hope. There it is. Well, that's a tight fit. Okay, so then once you've turned on the power there, if you can get the battery pack back in, this folds down and he's got tail lights. So it can go right. Evidently, it can just go left. That's all it does. Come on, buddy. Yep, remote has stopped working. Okay, I'm gonna put him out of his misery because he's just gonna wear his battery down. No, stop. Well, I'm having a terrible time. I can't even get it to turn off. All right, there we go. Well, I'm gonna have to see about that one and whether there's something I'm doing wrong, but the buttons are supposed to make it go different directions, like forward and backward, not just around and around. Maybe the last one we've got that we can look at. This one is an ultrasound sensor. So it's sending out ultrasound and listening for the echo, and the time it takes for the echo to come back along the speed of sound will tell distance. On the other end, it's reading some number. And it's trying to set this up so that it can measure speed. So by taking ultrasound readings of an object moving, it's trying to report the speed. So if I come really fast, I get a bigger number. And if I move slowly, it'll report a smaller number. So the idea here was to build essentially a radar detector for a kid's toys. So you could see what, the speed of your Hot Wheels were.
Cool. Another fun one.
So as you can see, there's just a lot of creativity and imagination people are using. I think I have run through everything that's sort of out and about and talked with each of the students who are here. So I'm going to take us down the hallway a little bit so we can talk without disturbing them anymore. Does anybody see where I put my iPad? I carried it around for a long while. Anybody see an iPad just sitting around somewhere unloved? Yeah, it's going to show up eventually. Great, thank you. So at this point, if you have questions about things, I'll get to a place where it's a little quieter and you can ask questions. If you're interested in the other projects that I'm doing this semester, I've been advising students in my pre-med course as they make videos for extra credit. So I'm teaching first semester mechanics for pre-meds. This is my lab. It used to be an equipment closet when we built the building. Then we were allowed faculty member and we needed a lab for them. So I moved out of the lab and into the equipment storage because that's really all I'm doing anyway is storing shit.
That's where we used to put the liquid nitrogen.
Yeah, among other things.
Yeah, I remember.
Yeah. There are pieces of the trebuchet in here. This is part of a soon-to-be radio telescope antenna. I have some equipment from Symphonic Wind Ensemble because for the fall anyway, we were playing out in the parking lot where they had a tent. This is the main telescope drive, which has been damaged by mice. And so I need to open it up and figure out if it's reparable. Like I'm hoping it's just chewing on cables and that can be replaced. These are telescopes from the observatory because when we got the mice in the observatory, I took out all the good stuff. So yeah, this is where we keep all the stuff. But I'm going to set up here and take off my mask and find out how all of you are doing.
Breath of fresh air.
Yes. Oh my gosh. And Phoebe, see that box that says Prime?
Yes.
Yep.
That one's yours.
Ah.
You want to tell them about your project?
Sure. Yeah, my project was a mushroom cultivation chamber. So it measured humidity and temperature and used some relays to control those parameters. And now I work in indoor farming. So yeah.
Oh, apropos. So you probably don't need the one you built here. You've got others, right?
Yes, we have bigger ones now. Paula, what's up with all of the mini LEDs? What are they called? The
Neopixels.
Neopixel.
That's a brand name for Adafruit stuff. Adafruit Industries is that female-owned company in New York. They have specialized in making hobby-level electronics more widely available and doing really good tutorials. So if you're trying to learn how to do something, Adafruit and SparkFun have both been really helpful for my students. Neopixels are a red, green, blue LED. So they actually have 3 LEDs inside a single package. And instead of having to address each leg of the LED independently, what you're doing is sending a data line. And so you can take a series of these, string them together, and essentially address each of them and have them do something. So it's easy to do color sequences. It's easy to do color fades. So it's basically a hyper programmable single pixels. The problem is that because they're so tiny, they're really meant for surface mount soldering. And so we're a little limited. In my ideal world, I would be learning how to do enough like EagleCAD or something to make boards, have students actually be able to fabricate a printed circuit board and populate it with surface mount devices. We haven't gotten there yet.
Gotcha. Thanks. Also, I didn't catch the exact details of that one dice project, but it sounds like he was having trouble with a narrow input signal. Do you think that maybe an op amp or external ADC could be a potential solutions there?
So in terms of getting noise in for the for seeding the random number, yeah, you may have a point there if we could change the gain. The other thing I haven't talked with him about was there is a feature in the Arduino where if you want to expand the sensitivity, you can have it look at something other than 0 to 5 volts. Right now, it's automatically digitizing 0 to 5 volts into a 10-bit number. So you get, or no, is it 8-bit? No, it's 10-bit. 1023 is the max. So you get, the digitization you're going to get. If we put specific voltages into a couple of spots on the Arduino, we can change that digitization to
create references. Neat.
Yeah. Yep.
Cool.
Yes, exactly. Different reference voltage.
Sweet.
Yeah. So can we go around and have people tell what they're doing? What's your gig? Andy, how about you? You look like you're smiling. I'll pick on you.
Well, no, it's just good to see you, Paula. It's been forever. So
I know it. When I saw all your faces, you couldn't see under my mask, but I was smiling so big.
Oh, well, we missed you definitely. Hi, everyone. My name is Andy Hira. I graduated in 2004 and did a whole bunch of stuff for a while in the golf industry. Worked for a bunch of them as an engineer building basically laboratory devices for testing golf clubs, whether they're breaking them, blowing them up, testing the metallurgical strength and tensile strength and all that, and basically making sure that when you go golfing, your shit doesn't break. So after a while, I got out of that and I went back to grad school in data science, got my master's in that, and have been working on the US Air Force contract for about 22 million different ECGs that I'm trying to predict arrhythmias with. So that's been challenging. And then I recently got hired by Uniformed Services Health Sciences, which is where the Armed Forces trains their doctors. And I'm doing cardiovascular research with them now on like a bunch of PhD projects that are way smarter than I am. And I have no idea what any of them are doing, but they're all like, hey, can you throw a model at this? And I'm like, sure. Let's see what happens. So that's what I've been up to.
Cool.
Yeah.
One on my screen is Lisa. What are you up to?
I'm Lisa. I graduated in '98. I'm trying hard to decide if my claim to fame was either my crazy lab notebooks or catching an oscilloscope on fire. And Paula remembers, I think, both of these.
That was memorable. Yes. That's
So I had a lot of fun with it. I taught physics and chemistry at the high school level for a number of years. I now live up in Mid-Coast, Maine, where I run a bed and breakfast and also run an inclusive preschool program serving kids with special needs within an inclusive program with about 100 students. And so loving that side, we do science things every day. They would love these little cars and things. But a lot of what you've showed us today is foreign to me. It definitely is a big change from when I was in electronics, and I think I would have enjoyed this even more. So it's cool to see.
Yeah, we really didn't develop this switch in directions until it was after I was out of the AP office. So it was probably about 2011-ish, I want to say. I had a sabbatical that had been delayed by going to do administration for a while. And I just took the sabbatical to do a bunch of stuff that I'd been wanting to do. And one of them was learn what the hell Arduinos were and how to use them.
I love it. The creativity that your students are able to incorporate into their work now is just so interesting. It's so engaging and different from what we were doing.
Yeah, it is. It's a lot of fun. It's definitely, I mean, it's controlled chaos to try to manage it all. But
we were controlled chaos.
Yeah,
We weren't
always
always
is.
controlled either. We were just chaos.
Yeah, okay, fair. You are not wrong. Phoebe, what are you up to? You said indoor farming.
Yeah, I was class of 2020, and I worked in plant science, in photochemistry for a little bit in an indoor farming company, and now I've transferred into the lighting engineering side of things at the same company. So, yeah.
Cool. Matthew Roth, are you still in there? Haven't seen your face, but
yeah, my camera's not working for some reason. But let's see. Well, for a number of years, I was working in the glass and optics industry, making doing business development and new product development for different types of optical materials, as well as ceramic optics. And I was working for a decent sized company, was having fun. And now I'm off with basically a new startup. A Scottish company wants to expand into the United States. So I am doing freeform optics, which we make using a CO2 laser. They can be micro and macro optics, and we make optical arrays with that, which are used in a number of different applications, but a lot of high power applications. So heat treating, welding, laser weapons, but also things like medical lasers, etc. Wave division multiplexing for telecom industry, and anywhere you can think of a freeform optic that needs to be made, we can customize it and make it in a day using a CO2 laser. And it's a pretty neat technology, but I'm basically taking it as I've got a little bit of skin in the game and doing a startup, basically new plant in the United States. So that's fun.
Awesome.
So you said something about ceramic optics. What are ceramic optics? I don't know that I've heard that term before.
I was doing work in developing magnesium aluminate spinel. So that's infrared transparent optical material. So a ceramic version of that. But also silicon carbide mirrors for multispectral imaging systems that either go into space, telescopes that are doing intersatellite communications, or satellite uplinks from space to the Earth or to space, or like I said, multispectral imaging systems that would fly on helicopters or remotely piloted vehicles, things like that. So anything where they want to have a very stable, thermally stable mirror and telescope system with wild temperature swings, things like that. So.
Oh, okay. All
Yep.
right, cool. Next person on my screen is Aaron. Are you there?
Yeah, can you hear me?
Yeah.
Yeah, so I am class of 1990. I've been doing microprocessing for 30 years. So computer chips, flat panel displays, MEMS, all within an hour's drive of Toledo, Ohio, believe it or not. You wouldn't think that's possible, but I've managed to make that happen.
It's up by my parts.
I'm sorry?
That's up by me where I grew up in Angola, Indiana, about an hour away.
Yeah,
from you.
okay, yeah. Well, I'm originally from Toledo. Well, originally I'm from Austin, Texas by birth, but grew up in Toledo. And anyway, so kind of decided to come back home to Toledo. And for a variety of reasons, I've decided to look into a career change, probably into neural networks, deep learning, that kind of thing. So software, actually.
They're very confusing. I can tell you.
Well, I love it. I actually had an interest in it when I was at Kenyon, and one of my senior projects was actually to build a neural network, just a very small one, 2 neurons using op amps. And if anyone's familiar with it, it was essentially a hop field network which served as a memory. And anyway, I loved that. It was a lot of fun, and kind of look forward to getting back into this. It's something I've always been interested in, and would like to try it again. And on the side, I've purchased an Arduino, haven't worked with it yet, and but I've gotten into astronomy pretty heavily in the last half decade. So that's more physics that I've been doing. So
cool.
So
When you mentioned neural networks, I had browsed through the chat after I sat down here, and somebody was saying LIGO, what's LIGO Lab? We have younger faculty members just recently tenured who have been LIGO collaborators. They did LIGO stuff, laser interferometric gravitational wave observatory, in grad school. And
cool.
They started teaching here in July, and the first gravitational wave detection was September. So Kenyon's actually on the discovery of gravitational waves paper. That was their affiliation.
I did not know that. That is just beyond
awesome.
Fantastic. That's
Even
great.
cooler than that, though, are some of the stories around it, because that first detection, they were still in engineering time. And one of the two, this is a young couple, Maddie, the work she does on LIGO is the calibration system that turns the raw signal into calibrated strain. Strain is the quantity of merit that tells us how strong the gravitational wave was, and that's what we link back to try to figure out mass of the inspiraling objects. When the event happened in engineering time, she got this frantic text message, or it's actually Slack, but basically a text message saying, "Is this a test injection?" Because they saw an event that was so big, they thought that it was test. And she said, "No, I haven't written that code yet. I've had to get ready for classes." So she was one of the first people to get contacted because they were so, like, is this real? Should we be pursuing this? Fast forward a couple of years to the first detection with an electromagnetic counterpart. If there's electromagnetic radiation coming out of the in spiral, then one or both of the objects have to be neutron stars. If the merger is 2 black holes, you just can't get any E&M out because they're already inside their own event horizons. So if one of them is not a black hole, then you can get, in the in spiral process, you can also get like gamma rays out of it. And they had set up a collaboration and a network so that events that were happening in LIGO were then reported to essentially the modern day version of a telegram service telling astronomers to turn their telescopes here. And they were able to pinpoint the object to within the size of a banana held at arm's length. So they knew where to point the scopes. And they found light. They found gamma rays and a signature of a decaying what's called kilonova. A kilonova is less energetic than a supernova, but a kilonova is caused by the destruction of a neutron star in one of these inspirals. The guy in the team who was there were 3 teams in LIGO that could do neutron star calculations, because everything they had found was black hole, black hole, black hole, black hole, black hole. But Les Wade, the other faculty member here, had been working with a student to do neutron star equation of state. So trying to figure out how neutron star material would respond to pressure and temperature and density. And that code was what they needed to model the masses of the objects in this thing with the EM radiation, because they knew one of them was a neutron star. So he was getting calls about this, and this is like August. His summer research student, who was starting to do honors the next fall, had gone home. And Les was calling him and saying, look, you can't talk about this to anybody, but I need you to get on a computer right now. We need to run your code to find out what the masses of these objects are. So
oh my God, that's so cool.
Twice our folks were really on the front lines. And the other thing is LIGO is really tight-lipped. They embargo everything. We didn't hear about anything until it was publicly announced. But they're frantically doing stuff for the collaboration, trying to figure out what's going on. And they are on the front lines. So it has been so cool to hear those stories.
That's fantastic.
And our students are doing the work. So when you talked about neural networks, one of the projects that they're doing with the calibration side of things is to try to use neural networks to improve the response to events that might mimic gravitational waves. If you have a truck rolling by, that's going to cause the mirrors to vibrate. And it's a way bigger signal than the inspiral of 2 neutron stars or 2 black holes somewhere, halfway across the universe. So they've got a lot of active detection, seismometers and microphones and all sorts of things that feed into this channel of possible noise correlations. And that's why 2 LIGOs are important, because the one in Louisiana has different trucks going by than the one in Hanover.
Yeah, you gotta,
Yeah, exactly. But by using a different kinds of neural networks, they're trying to now use machine learning to improve the glitch detection.
Well, I'd love to talk to them about that, because that's what I do. So they're very confusing. Neural networks are basically function approximators, and that's the problem with them, is that when you go to explain the black box, you can't necessarily do it. You can merely get the object detection, which is why they're used mainly for that. What types of networks are they trying? Convolutional, recurrent convolutionals?
They're certainly using convolutional, and there was one that was called ANN. So that associative neural network, I think it was.
Yep.
So at least ANN and CNN. I just recently saw a talk, and the one who would know more is the young woman who did the little rotating character for her little brother. She's actually doing some of that coding. So she's doing
Very cool.
coding neural networks right now.
Those are very difficult. And she should also look at LSTMs. They're long-term, short-term CNNs. So they have what's called memory gates, and allow you to retain a little bit of state memory while you're working your way through your epochs. And so as you're learning more and more from the data and converging towards your eventual target of what you're trying to hit, it will help at least sort of improve the short term. There's all sorts of combinations. That's the problem too with deep learning, is that there's absolutely no rules. It's such a weird field in the fact that neural networks have been around for forever, but the computational requirements weren't there. Well, now the computational requirements have caught up, but there's absolutely no rules, because that's actually what I did for my grad school thesis. Was I mapped the human body doing exercises, because I wanted to map stationary exercises and see if I could actually predict both quality and what they were doing just by loading in a bunch of sensor data from 3 of these little guys. And I wasted a lot of compute time on a supercomputer. We burned about 2 months for the forests trying to basically random search deep learning grids about 7 layers deep. And we found out which model worked best, which is it was actually a 2D convolutional. So as opposed to a 1D convolutional that works in one dimension, the 2Ds are mainly used for images. And it's they're very useful, but they're very difficult to explain. So that's the only downside of deep learning networks, which is why some more traditional models might be a little bit better, especially in their cases where if they know the transition probabilities of the neutron star from state to state, something like a hidden Markov model might be better, because that deals specifically with those distributions being constantly resampled and looking for when they're outside of those means to basically serve as an anomaly detection. Sorry.
Okay,
That was a lot.
I'll try to pass some of that on. I'll try to pass some of that on to Maddie, at least what I understood of it, and that you might be
Yeah.
in contact.
Feel free to give him my email or something. I'm happy to chat with him about it. Same goes to you, Aaron. If you want to get into neural nets, I'm happy to chat with you about it. They're a fun field, but they're confusing as hell.
Cool. So Zach, what are you up to? You still there, Zach? Yeah, cool. I'm not hearing you yet. I saw you unmute, Zach, but I'm not hearing anything.
Hard key mute, maybe.
To me, it looks like he's still muted.
Okay. Well then, Steven, how about you?
Okay, we'll give this camera a try. I'm not sure how this is going to work. Yeah, since Paula told us how when she was born, I'm class of '74, so just for scale, Paula was 10 years old when I graduated from Kenyon. After that, I went to grad school at Case Western Reserve University and did a dissertation in some aspects of how woodwind, single reed woodwinds work. And then because nobody can get a job in this country doing musical instrument physics, I ended up in the acoustic transducer business, first in the sonar world until the end of the Cold War. That then became a really terrible business to be in, and I moved to commercial transducers for a company that makes tiny microphones and loudspeakers in hearing aids, and these days they're in a lot of other places too. So for the last 16 years, I've been on research faculty in the graduate program in acoustics at Penn State, trying to make a funded research program out of industrial funding for things having to do with acoustic transducers. This year, I've started on a 3-year slide, reduced commitment every year toward retirement. So at the moment, I've got a 75% appointment that gives me 25% to do fun research instead of paid research, and we'll keep headed in that direction. The thing that I've turned into a fun project is to go back to some of the physics that I did in grad school, and I've got a SimScape model of the clarinet that can actually produce some sounds that sound pretty clarinety. So that's a fun thing that maybe will end up being shared around a bit.
Cool.
That's where I've been.
Nice. Looks like Zach again is here. Zach logged in again. Maybe you can say hi.
Hey there, can you hear me?
Yeah, cool.
All right, sorry, I had to go get my work phone. I guess I'm, too much of a privacy person. I was using the web-based version on the other one, so I could hear you. And anyway, yeah. So I'm Zach, class of 2006. Wanted to say that definitely some fun projects there, and sounds like a really cool class. And glad you're doing fun stuff. In terms of what I've been up to, I don't know, maybe it's been 6 or 7 years now. Doing a variety of projects involved with kind of rockets and satellites and stuff like that, and getting to do kind of a touch on a variety of different subjects. Yeah, it's a bit sensitive, so I can't go into the details, but doing a lot of really fun stuff, and definitely physics based. And if the physics don't work, that's a great sign. That's somebody's idea. Should not be carried forward if or funded or something like that. If it seems to violate physics, so that's always a good first check.
Well, the other thing I want to mention is how valuable it was for our student. Last year, actually, like the first summer of the pandemic, Zach was able to offer one of our students a remote research opportunity building a radar device. It was something that was really at the right level for that student to begin to take some of the electronics learning and try to apply it. And I really, and Zach just mentored him through the whole thing. So I never got a chance to say thank you, but thank you so much, Zach, for doing that for Rodrigo.
Oh yeah, it was definitely not without its, bumps and stuff along the way. It was the first time I'd done that, and obviously, remote and stuff. But yeah, I thought that was pretty cool. I was glad I was able to do it, and hope you enjoyed it. And that did remind me a little bit with the we had an Arduino, so that when you were going through some of those projects.
He definitely did enjoy it, and he really, I think, grew in the process. And you've helped him sort of gain some confidence in his ability to work independently. So that was really huge.
Excellent. Yeah, well, I'm good. I'm glad I can be of assistance. If I could get more of those for free, I would send them your way. I don't know, and maybe this is a conversation for another time, but would that be interesting for, I don't know if it's part of a class, or I don't know if you have a club or something, like kind of put one of those together?
It might be the sort of thing that we would want to do with Roar. Maddie and Les Wade, the LIGO collaborators, when they came here, also wanted to start sort of a not so much a journal club, but an astronomy entry-level research opportunity. So yeah, we do some things like read condensations of journal articles, but more importantly than that, the students are learning to do some entry-level pulsar research. Pulsar candidates are identified automatically, but they can, if you just look for repeating signals, you often find radio frequency interference. And so a radio telescope scanning the sky for pulsars will find a whole bunch of stuff, and they need somebody discriminating who can look at the signals and try to figure out what's going on. So we've had our students learning how to do pulsar ranking. So they look at the candidates and upvote or downvote them. So it's a little more than citizen science, because it takes a good bit more training than that, but it's an entry-level research opportunity. And I think we're going to be putting ourselves out of business, because one of the seniors is doing an honors project on machine learning to do pulsar candidate ranking. So if he gets his system working, we may be out of a job for the first years.
So
building
that's
a radar
progress,
would be a
though,
good
right?
thing.
That's a sign of progress.
It is the nature of progress. So that might be something where we could then next year do something, say, okay, we're going to build a radar, and it's going to be, a project where everybody gets a hand in and learns a little.
Yeah. Please let me know about that. I can't make any promises.
Sure.
But
Well,
yeah,
and in terms of funding, we have funding to actually buy materials too. So we wouldn't be asking you to do it for free, but if you have the expertise, we might pick your brain.
okay. I don't know if I have the expertise, but I've helped at least once.
Yep.
I'll throw it if I haven't exceeded my time. I thought of a couple other astronomy type ones. Is that over the last few years got to see some pretty cool telescopes, and like got a tour of the ones out at Haleakala. So that was pretty fun. And gonna be maybe finally. I haven't been doing, at least for work, kind of hardware type stuff much lately, but probably at some point or another this spring or summer going to be actually controlling a telescope. It's 36 inches, I think, or something, just around Massachusetts. So it's not a very great spot for a telescope, but anyway,
neither is Ohio.
It's kind of like astronomy, I suppose. Anyway,
Cool.
it was good to see you again, and thanks for sharing and
Well,
doing
thanks
this
so
with
much,
the
everybody,
kids.
for coming. It's probably past time to sign off, and Kim probably needs to go home and have her life back. I really appreciate the fact that y'all sat in and looked at the student projects and stuff. I have a lot of fun doing this with the students, and I want them to have this sense of pride that they're learning some skills and that other people care. So you guys have been hugely helpful in helping them understand that what they're doing isn't just for a grade, that it's for the learning experience and being able to talk about your successes and your failures, and that's great. So Lisa, you were saying something about Arduinos and kids. I teach a course now for non-science majors in the 100 levels. You know how we have the astronomy classes and whatnot. I have one now that I call Creating with Gadgets, and it's Arduino electronics for history majors or art majors. It fills every time we offer it, and they do the same things with less oscilloscope work. They don't use oscilloscopes. I figure if they can draw a schematic and recognize a voltage divider, that's probably enough. And Phoebe was actually the TA for that course just the last iteration. That was the one we did at the makerspace. Mount Vernon now has a makerspace, except it's been closed since COVID started. So I don't know if it's still a makerspace or not. But it's a fun course where the projects go even wilder because there's no science background. So they're trying to do all sorts of weird things.
Love it.
Yep. Yep, it's good. So thank you all, and I hope you keep in touch. We're getting through the pandemic here. We're still masking all the time. We haven't had any big outbreaks, knock on wood. Tomorrow is the last day of exams, so everybody's going to go home. What we've taken to doing is when everybody comes back, either after Thanksgiving or when they come back in January, there'll be a round of testing for all the students. There's some quarantine housing, although that's been really tough this year because with our really good track record during the first year of the pandemic, we never had to cancel classes. We became very popular. And so we had 600 new first year students, which is ridiculous. We usually aim for like 490.
Yeah,
So at the time, my daughter Sam was working for international studies and off-campus studies. They figured out how to run a program in Denmark for 50 of the first years, just to get them the hell off campus. There are 30 people who are going to finish all of their requirements this semester, so that'll clear up some housing space. We rented some apartments out in Apple Valley for overflow, so it's just ridiculously crowded, and trying to, you know, accommodate everybody and get classes enough for everybody has been wild. It's a good problem to have. I should make very clear I'm not complaining. This is awesome. But there is some management when you over enroll by, you know, something like 20%.
You only have a certain number of resources.
Yeah. So we're doing well here and getting through the pandemic. I think it takes a toll, even though this semester has been closer to normal. Like there were a cappella concerts this year.
Oh, really?
And you'll be happy to know there are physics majors in Chasers right now.
Oh, yay.
Hey, three
Glad
of
to
the guys.
hear it.
Yep.
Oh, cool.
Yeah. So it's been a little more normal this year, but it's still masking in all the academic spaces and you know, people being pretty cautious. And if somebody gets the sniffles, just stay home.
Oh, yeah.
Is the policy. So we're doing a whole lot of makeups all the time. I was doing at the start of the semester, I was doing them by Zoom.
Yeah.
Yeah, start of the semester, I was doing makeups over Zoom because there were so many people. Like, at least I could get all 8 of them. They were in quarantine, right? So they couldn't come in and do their makeups, but they could all get on Zoom, do their makeups, and they didn't get behind. So that was good.
As always, pick apart the problem, find a solution.
I keep promising. Yeah. I keep promising we should go. Thank you so much for coming to play with me. I'm still having a great time teaching physics, and when that stops, that's when I retire.
Very glad to hear that, Paula. Take care, and thank you for this. This was wonderful to see all of you.
Thanks, everyone. Have a great
Thank
night.
you.
Thanks,
Yes,
Kim,
thank
for
you.
setting it up.